Understanding log-normal distribution, definition, characteristics, and applications. A log-normal distribution is a statistical distribution derived from taking the logarithm, typically the natural logarithm, of a set of values that are normally distributed. It is important in various statistical and financial analyses, especially in cases where the data being modeled cannot be negative. This article explores the properties of both normal and log-normal distributions, their significant applications, particularly in finance, and how to work with log-normal distributions using Excel. Defining normal and log-normal distributions. Normal distribution. A normal distribution is a symmetric probability distribution characterized by its bell-shaped curve. It is defined by its mean and standard deviation, and within a normal distribution. Approximately 68% of the data falls within one standard deviation from the mean. About 95% falls within two standard deviations. Nearly 99.7% lies within three standard deviations. This property of normal distribution makes it a fundamental concept in statistics, serving as the basis for many statistical tests and interpretations. Log-normal distribution. Conversely, a log-normal distribution arises when the logarithm of a variable is normally distributed. This means that if the random variable \x is log-normally distributed, then \ln x follows a normal distribution. The log-normal distribution is positively skewed, meaning it has a longer tail on the right side, accommodating scenarios where values cannot drop below zero. Mathematical properties. A log-normal distribution is completely defined by its parameters. Mean, the average of the logarithm of the variable. Standard deviation, sigma, the variability or spread of the logarithm of the variable. The log-normal distribution can be expressed mathematically as \f(x) equals \frac 1 x \sigma \sqrt 2 pi e caret dash \frac ln x \mu caret 2 sigma caret 2 \. For x greater than 0 \. Applications of log-normal distribution. One of the most prevalent uses of log-normal distributions is found in finance, especially in stock price analysis and investment returns. Stock prices. Stock prices are typically modeled using a log-normal distribution because they cannot take on negative values. In investment scenarios, the returns on investments can be represented by normal distributions. The prices themselves are best analyzed with log-normal distributions. This relationship aids in identifying compound returns, providing a better understanding of potential investment risks and rewards. Reliability engineering. The reliability of systems can also follow a log-normal distribution, as the time until failure for certain components may be affected by a multiplicative process, making log-normal modeling appropriate. Real estate and economics. Log-normal distributions are applicable in real estate markets where the prices of properties often span several orders of magnitude, resulting in right skewness. Economic indicators, such as income distribution, also frequently exhibit a log-normal distribution since income cannot be negative and is often highly skewed. Utilizing log-normal distribution in Excel. Excel provides a built-in function to handle log-normal distributions through lognorm.dist. The function is defined as follows. Excel. lognorm.dist, x, mean, standard_dev, cumulative. Where x, the value at which to evaluate the function. Mean, the mean of the natural logarithm of the data. Standard_dev, the standard deviation of the natural logarithm of the data, which must be a positive number. Cumulative, a logical value that determines the form of the function. If true, it returns the cumulative distribution function; if false, it returns the probability density function. Example. Suppose you want to calculate the log-normal distribution for a stock with a mean log return of 0.05 and a standard deviation of 0.1 at a value of 1. The function in Excel would look like Excel equals lognorm.dist 1, 0.05, 0.1, true. This formula calculates the cumulative probability for the log-normal distribution at that particular stock price. Conclusion. The log-normal distribution serves as a vital statistical tool in various fields, particularly in finance where it helps model stock prices, investment returns, and economic data. Understanding its definition, properties, and applications can enable better decision-making and analysis. Furthermore, tools like Excel enhance accessibility, allowing statistical modeling to be efficiently performed even by those who may not have a strong statistical background. The knowledge of how to apply log-normal distributions can provide a significant advantage in analytical scenarios.